Welcome to Beginner Python, Supervised vs Unsupervised Learning. In this lesson, we will discover what supervised and unsupervised learning are. We will see how Python can help you use these powerful machine learning techniques. By the end, you will know the basic differences and try out some practical code yourself. Running the cell now. After this cell, try explaining in your own words what you think supervised learning means. If you are excited, give the video a like now before we start. Now, let us talk about machine learning. Think of it as teaching computers with data. This comment just reminds us that we are starting with machine learning. Machine learning means letting computers learn by looking at examples and patterns. This line tells us that supervised learning means we already know what the right answer should be. We provide examples and their labels. This line explains that in unsupervised learning, we only give our data to the computer, and it tries to learn patterns without knowing what the correct answer is. Running the cell now. Can you think of something you have learned with lots of examples in your life? People sometimes call supervised learning a learning with answers. What is supervised learning? In supervised learning, you give the computer data and the correct answers. For example, the list of fruits with their names, or pictures with the things in them. The computer learns to predict answers for new data. Running the cell now. Try listing a few things you learned from examples and answers. Supervised learning is used all the time, like recognizing handwriting or blocking spam. Here, we create a small data set. The data has fruits and labels are their colors. We are adding a reminder that we are making a dataset for supervised learning. The fruits list contains some fruit names, just as examples. The labels list has the colors matching each fruit, known as labels. This prints the fruit and color for the first example, showing how the answer is known. This prints the third fruit with its color. It is just another example. Running the cell now. Now you try, change a fruit or color in the lists and run again. This shows how supervised datasets have matching data and labels. What is unsupervised learning? Unsupervised learning is when you only have the data and no answers. The computer tries to find patterns, groups, or structures in the data on its own. For example, grouping customers by their shopping habits. Running the cell now. Can you imagine learning about new things without knowing the right answers? Unsupervised learning is good for exploring and discovering interesting patterns. Let us look at a simple list of shopping amounts. There are no labels, just the data. This reminds us that the data is for unsupervised learning, so no answers. The shopping list shows what someone spent in dollars. These could be different people. This prints out the shopping amount so we can see them all together. Running the cell now. Try adding your own numbers. What patterns do you see in the data? Maybe some people spend much more than others. Now, we will show the difference between supervised and unsupervised data side by side. This is a note just explaining our goal for this cell. We print that supervised learning has answers using our fruit example. This prints the example fruits. This prints their labels or answers. Now we print that unsupervised has only the data, not any answers. This prints the shopping numbers so you can compare. Running the cell now. Consider which tasks in your life have labels and which do not. Pause here and see if you can explain the difference out loud. How do we use Python for supervised learning? Supervised learning uses labeled data to train a model. Common models, classification and regression. We will try the scikit-learn library for easy examples. Running the cell now. Try looking up what a classification and a regression mean for practice. Get ready to see some Python code in action. We will use a library called scikit-learn. It has tools for machine learning. The comment just says what we are doing next, importing a library. This line imports a special tool called Decision Tree Classifier. It is used for supervised learning. Running the cell now. If you do not have scikit-learn, ask your teacher or try installing it. Importing often comes first in Python machine learning projects. Let us train a decision tree to predict fruit names from size. We are starting a simple supervised example. This time, we use numbers as features. These are our samples, or features. In real life, it could be any numbers describing things. This list contains the answers, or the labels. Here, that is the fruit name for every sample. Now we make a decision tree. This tool learns patterns between features and labels. Here we train ORs fit our model. The tree looks for differences between apples and oranges using the sample data. We ask the trained model to predict the fruit for size 1. It uses the patterns it learned. We do the same, but with size 4. Notice how the model can say if it is an apple or an orange. Running the cell now. Change the numbers in X or Y and watch what happens to the predictions. Try using your own made-up data. How do we use Python for unsupervised learning? Unsupervised learning lets the computer find new patterns in data without labels. We will use the k-means method from scikit-learn to group numbers. Running the cell now. Take a guess, how many ways could you divide the shopping numbers from earlier? Grouping like this is called clustering. Just as before, we need to import the tool we plan to use. The comment lets us remember we are doing clustering next. This line imports k-means, a tool to group data by similarity. Running the cell now. It is safe to run this even if you already have k-means imported. You can build lots of machine learning ideas just by importing tools like this. Let us group shopping amounts into 2 clusters. This is another supervised reminder, but now we find groups in data. We import NumPy, a package that helps us with arrays and math. Here, we turn our shopping list into a NumPy array and shape it for the algorithm. We make a k-means model that will split the data into 2 clusters, or groups. Now we train the model to learn where the groups are. Finally, we print which group every shopping number belongs to. The computer found this pattern by itself. Running the cell now. Try changing n_clusters and see what changes in the labels_output. Unsupervised learning helps us explore data without needing answers. Now, let us see where the model puts new shopping amounts. We are showing how the clusters can be used for new shopping numbers. Here, we make 2 new shopping amounts, 7 and 55, and format as needed. This uses k-means to predict which group each new number should be in. We print the groups for the new numbers. The model can split unseen data into groups, based on what it knows. Running the cell now. Test with your own new numbers to see where they go. Could you use this idea to group your friends by spending? Summary for supervised and unsupervised learning. Supervised learning uses data and answers. Unsupervised learning uses only data. Python makes both easy with the right tools. Running the cell now. Give a quick recap to yourself, say out loud when we use supervised or unsupervised learning. If you are learning a lot, be sure to subscribe and share this video. Here is a new challenge, teach a model to name smaller or bigger animals. We are trying supervised learning again, now with animals and their sizes. This list uses numbers to stand for animal size. These are the labels. Each size matches a type of animal. Now we test what happens for animal sizes not seen before, 2 and 12. We set up another decision tree for this animal dataset. Fit, or train, the model using our training samples and labels. We print what the model thinks for size 2. It chooses the most similar animal. Try size 12 to see what the model predicts. It is like guessing based on training. Running the cell now. Try adding your pet or favorite animal and see if the code can predict it. See if you can make the model predict a size that is in the middle, like 8. Now, let us try unsupervised learning with people heights. We want to group people by height using unsupervised learning. No answers, just the numbers. This list shows a few heights in centimeters, which could be people in class. We turn that list into a NumPy array for easier math. Now we make a k-means model to split our data into 2 groups. Fit, or train, the model so it finds patterns in heights. This prints the group number for each height in the original data. Now we predict which group someone with height 170 would belong in. The algorithm chooses for us. Running the cell now. Try using your own height or your friend's heights. How would the clusters change if you chose a different n_clusters value? Mini project part 1, Fruit Color Predictor. Imagine you work in a fruit market. You want a program that predicts the fruit's color from its size. Let's prepare a dataset together. Running the cell now. Write down a few fruit names and colors before you code. This is how real projects begin, with real-world problems. We are building a supervised model to predict color from fruit size. This challenge uses numbers for size and color names for our labels. Here are some made-up fruit sizes. The matching colors for each size are written here. We set up the decision tree for color prediction. Fit or train the model using our size and color lists. Try predicting color for a fruit of size 7. Does it match what you expect? Predict color for size 10, a size not in our data. The model decides based on what it learned. Running the cell now. Add a new fruit size and color pair, retrain, and try more predictions. You can now use machine learning for small tasks like this. Mini project part 2, Find unusual shopping behavior. Your store wants to spot shoppers who buy way more than others. Let's use unsupervised learning to discover these shoppers. Running the cell now. Try thinking of other real-life examples where finding groups would be helpful. This project can help stores offer deals or watch out for fraud. Let us find high-spending shoppers in our little store dataset. We create a list of shopping totals for fake customers. Make it a NumPy array so k-means can work with it. Here, we choose to split people into 2 clusters, like normal and big spenders. Train the model so it finds those groups. Now, we look at every shopping amount and see which group it was put in. This prints each customer's total and group number. Grouping helps us spot patterns quickly. Running the cell now. Try making a group for 3 types of shoppers instead of 2. Group 1 can mean typical, while Group 0 shows outliers. Now, let us guess which group a new shopper is in by asking for their amount. This is a reminder to check a new customer we have not seen before. We ask the user to enter a shopping total. The input comes in as a string. Convert that input to a number so the computer can use it. Predict which group this customer belongs to using the k-means model. The print statement shares the group, so we know if this customer is a big spender or not. Running the cell now. Try typing numbers below 50 and numbers above 100 to see what groups you get. You can use input and machine learning together to make interactive programs. Troubleshooting and common mistakes. Check that your data and labels line up in supervised learning. In unsupervised learning, remember there are no labels. Watch for misspelled variable names. If you see an error, read it slowly to find the cause. Running the cell now. If you get stuck, check your variable names first. Practice debugging, fix a single typo, then try running again. Here are some final tips as you explore more machine learning. We use a comment to point out this cell is about tips and tricks. This print line reminds you there are many models in scikit-learn. Try some out. A print message encourages you to use your own ideas for datasets. Machine learning is everywhere. Running the cell now. Find a list from your favorite hobby and try classifying or clustering it. Be creative. The best projects start with things you care about. Try sorting something fun using what you have learned. A reminder that this is a challenge activity for you. Make a list of some movie titles. And here are their ratings out of 10. Sort the movies using their ratings so the best is first. This uses a Python trick called zip. Print a message showing our sorted movie list. Now, print each movie in order so it is easy to see. This shows how Python can make sense of favorite lists. Running the cell now. Try swapping the movie names and numbers and running again. See what happens if two movies have the same rating. Recap, what did we learn? Supervised learning equals learning with answers and labels. Unsupervised learning equals finding patterns with no answers. With Python and scikit-learn, you can try both easily. Great job sticking through the lesson. Running the cell now. You are now ready to explain these ideas to someone else. What will you try to build next with Python? Thanks for watching. If this was helpful, like the video, leave a comment, and subscribe for more Python tips. Share with a friend who wants to learn machine learning, too. See you in the next lesson. Running the cell now. Remember to subscribe and share if you learned something new. See you in the next video.